Hi, everybody. Of course, this topic can go quite deep, and we are just gonna scratch the surface today. But yeah, let's just discuss it afterwards. You are also free to just message me on Discord if you would like. But let's just get into it. So the scope of this talk will be to introduce you to how the sausage is made at Bogren Digital and how our UI implementation process has evolved over time, as well as what are the different tools and modules that we use to implement our UI. And I'm excited to share with you that we are open sourcing some of these modules today. The limitations for this talk will be that we are focusing on the native Juice UI. I'm not going to discuss web views or other type of render engines. Nonetheless, some of the ideas will apply broadly. So you can check out all the stuff that we released today here. I'm also going to show you this link at the end. Cool. And so basically, yeah, just a few words about me. I'm an audio software developer. I have been working on audio plugins for a couple years. I joined Bogren Digital 2 years back. We have released quite many amp sims since then. And then today for the demo, I'm just going to show you images of the one in the top in the middle. It's called the BDM75. It's inspired by a Marshall Plexi amp. And then if we kind of look at how the UI is composed, we can see that it's of course quite a simple interface. It has two switches, one dial for the gain, and then a couple other images. So, okay, let's just give you a quick overview of how our UI pipeline has been evolving over time. So initially, we just got like a list of images, kind of like a zipped folder from our graphic designers. And we would normally just manually assemble a PSD, like a Photoshop file as reference, just so we can get an understanding of how the layout will look for components. And then we would hard code the positions in our applications for that. In terms of using the graphics, the graphical assets, we actually like bake them into our plugin. So we use a single image set in order to like shrink the final binary size as much as possible. And that means that we resize them during runtime. And that also means that we noticed that on some types of displays, we had to do extra image processing of like downsampling images. We also ran into some trouble with image sort of like artifacts because of downsampling previously. And we also had some issues sometimes with the UI layout in terms of like the Z order of components when we were using the default like component ordering systems from Juice, particularly when we would like create most of our layout in sort of like the base class for our editors. And then in some product specific derived classes, we add a bunch of new components, and then the layout just doesn't look right. There are things that are rendering on top of other things that should be in the front. So that was always a little bit tedious to have to script that with every new product that we had. Whereas nowadays we actually have found a good like standardized document structure for Photoshop files that we can request from our designers to deliver to us as sort of like a single source of truth for graphics. It has like a very structured layer hierarchy. So that means that we can also export the images and also extract metadata of component positions. And then we can load them during runtime dynamically. And our images are still baked into our applications. So we still use a single high resolution image set and resample it as needed. But we did get a little bit better understanding of like how to combat all the resampling issues that we had before. And we also adopted a pattern we call the sorting layers for combating like this Z order problem that we had with some of the components. And then let's just get into the layout implementation really. I'm sure you have seen stuff like this for hard-coded positions in Juice. What I wanted to point out is that like this Juice live constant macro, if you're not familiar with it, we always found it greatly helpful. And if you build your apps with it in debug configuration, you will get that editor window where you can tweak the position of your components. It can be quite useful. And then what we used to validate the position of our components afterwards was something called the split view, which is another like tool that we implemented in-house, where you can sort of like render two components side by side and then drag between them. And then you can compare, for example, your UI implementation against some like reference image. So that always helped to have like that final step of manual inspection before release. Yeah, but let's just start focusing on the automated UI pipeline that we are using nowadays. So for that, we have developed a Photoshop plugin that can sort of export all the images that we have, as well as Juice user module for loading stuff dynamically. So these things are already live and publicly available if you check out the repository that I will share with you later. So what are the type of requirements that you really need to be able to build your UI in this kind of dynamic way? Well, you will have to come up with a standardized document structure no matter what kind of graphic design tool you use. So for us, for example, for BDM 75 in Photoshop, you would get a similar kind of layer structure where we basically have like a primary group for the different types of components, such as like buttons and switches and dials and whatnot. And then within that, we have like subgroups for each component within that type. So we would have two groups for switches there. And within those groups, we will have all the frames that that component will need to use, all the different images. So once we have that, then we can, of course, export all the images. And we have this functionality there where we can just export all our images. So what it will do is it kind of just iterates through all the groups, crops the image to the bounds of the component, and it's going to export all the different frames for that component. And then once you have all that, before you can also like, actually instantiate your components runtime, you will also need to develop an understanding of like the UI layout. In C++, you need some kind of a parsable description that you derive from the Photoshop file. So we have this other function there for generating that type of metadata from the Photoshop document. It's a pretty standard XML file. You can see that we define the entire bitmap size, the type of the component, what name it has, what kind of files belong to it perhaps, and what the position and its size is in the original bitmap, as well as we have some other flags, whether you are having raster or vector kind of images. And let's just see how that relates to the original like Photoshop file. Basically, anything that does not belong to a group, we will just treat it as a standalone like image component. And then in terms of the grouping of different types of components, you can see that up there we have, of course, like dials, just one dial called gain. So I guess this is a good time to point out that like this layout definition is completely derived from the name of the groups in the Photoshop file. So if they are basically like quite susceptible to typos, but I mean, that's what you get. Yeah, but of course, like we have the two switches, power and channel switches. So yeah, once you have all of this, then you can load it in the UI dynamically. So we have a UI loader module for that. That's kind of what it looks like when you construct it. One of the dependencies it has is this like binary asset loader, which just wraps around the binary data you would normally have in Juice. So you can just pass in like the usual function pointers to it. It's completely generic. And then you pass it in as a dependency to the UI loader itself. The other dependency it has is the UI container, which will hold all the components that get created during runtime. In order to support custom components, we adopted this sort of like factory pattern, where you can specify that for this specific UI layout, if you encounter these types of tags, then I would want this kind of component to be created. And yeah, once you do that, you can just call build UI, specify the name of your layout file, which gets also loaded from the binary assets. And then that's pretty much it. And if you look at how the window is sized afterwards, it becomes quite lean. You basically just have to set the size of your container, and then if you call apply layout on the loader, it will take care of properly sizing all your generated components. So what if you actually want to use vector graphics instead, and maybe you use Figma, and we don't really have an automation for that in-house, but we have done some sort of proof of concept tooling with it, where we discovered that you can prompt a large language model to interface with Figma through MCP servers. So that kind of provides an interface for large language models to interact with different types of applications. And using that, we could also kind of get like this is, for example, for the hard-coded UI workflow, where you will be able to extract the position and size of different parts of components there. And then, it will be able to generate C++ code for you. Another example is if you want to use this sort of UI loader system with dynamic UI stuff, then you can also instruct it to, of course, generate like an XML file for you, and then you can dynamically load things. So that can be quite useful as well. All right, so if you are using different types of images, you can still like specialize different types of factories. So here we have raster and vector images that can get loaded if you are trying to add multiple types of layouts on top of each other. And that's about it for layouts. And then we will take a look at Z-orders. So as I mentioned, sometimes we have issues with that. And this sorting layers pattern would help us to sort of set a very explicit layer order to components. And I think that maybe an even better example than this would be to think about like different types of UI. So you would normally have the skeuomorphic UI on the ground level, and then you want to show some kind of non-skeuomorphic controls on top of it. Maybe you will show some kind of menus, and then on top of it, you might want to display like the licensing windows that gets like the highest priority. If you assign this kind of layer orders to these different types of layers of the UI, then this sort of like manager or utility class will make sure that whenever you add new components to your main container, they will be inserted at the right level, and they will never be shown ahead in front of some other contending things. Okay, so the next topic will be to talk about smooth resizing windows, which is what we are normally doing, and it ties really into with resampling. And then normally with Juice, if you just put all your components and the integer pixel grid, you will get like this kind of jittery problem. This one is not really loading, but I guess you might have seen it when you are resizing windows, then components will just start to fidget around a little bit. One of the solutions to work around that would be to apply an affine transform on the container level. And that's kind of the easy solution. Then you can still set your component bounds to the original like bitmap sizes. Again, sorry, but if you check out the slides online, you will find that there are all these GIFs there. It's extremely smooth. It will look nice. The one problem you will have with it is that if you are applying some extreme downsampling, like trying to downsample it to half its size, then it will start to get blurry. And if you are using like third-party SVG renderers that rasterize it, and then you downscale it, and you are downsampling raster images, and it will look bad. So don't do that. But you could also consider applying a per component transformation, and then you could get better results in terms of the resampling that you can do. Again, this will look quite similar. I think it's not always as smooth as the container level transforms, but it's pretty close perceptually. So we actually have some analysis coming up using different quality metrics and comparing different display types as well as different OSs and talking about stuff like subpixel alignment and things like that that we will upload in the following days in this repository. As well as we will have some more stuff that discusses the image resampling sort of best practices. Some quick thoughts about that is in terms of quality. We prefer to use the Lanczos resampling algorithm, which is quite high quality, but you might want to consider doing things in linear space there to preserve grammar correctness. And then you want to do maybe downsampling in multiple stages, because that can help avoid some of like the artifacts that you get around high frequency detail in the images. And then you might want to consider other stuff like applying adaptive sharpening and kind of, I guess, like doing edge detection and stuff like that, and applying different amounts of processing on different parts of the image. Again, all of this is related to combating artifacts when you are using a single image set. So maybe it's like a very special case. But if you do that, then of course you might want to defer processing until the window is being resized, and you want to cache your components where it actually ties into doing stuff on a per component level, because then you can actually cache all the images for that given component. It's pretty hard to do that on a container level, and then things will become pretty expensive there on the CPU. So again, we will have some more stuff on that in the coming days, so stay tuned. And then the last topic I just want to mention is how do we actually evaluate whether things are correct or not. Basically, there is this whole field called image quality assessment in computer science. If you are, like in our case, we always have, of course, the original UI design, we compare against it. Then in this field of study, it's called full reference models that people apply. And these are what are called perceptual models. And to be able to carry out this image analysis, we created this tool called CRISP in the Grand Juice tradition of giving tools names with questionable acronyms. It's the Component Render Image Similarity Profiler. And so it can be used during runtime to sort of run analysis on your images of your component renders and then apply all these kind of perceptual models. We will have more, like this is also available in the repo, and you will see some kind of description of what these different models are. We also create different kind of error maps for each model for you. You can sort of run this during runtime, so it can do runtime analysis, and that's kind of it. And this is where you will find all of this. So thanks, I guess.